Hello, students. So let's do another example. Let's say now, instead of starting with a polynomial and asking us to interpret what that might mean, let's start with a problem and try to convert it to a polynomial. So let's say we want to know the number of ways to place K balls into 4 urns. So no urn has over 5 balls. Okay, so that's what we want to count. But let's think about this. I want to set it up as a problem where I have 4 choices for urn 1, 4 for urn 2, 4 for urn 3, and 4 for urn 4. So if I did something like this, well, think about what happens when I multiply this out. I have to choose a coefficient 4 different times because I have these 4 different pieces, and each time I'm trying to compute my terms out, and when I'm trying to expand this, I have to make a choice whether I'm going to take 0, 1, 2, 3, 4, or 5 x's from the first part. So this is 0 through 5, 0 through 5, 0 through 5, and 0 through 5. And this will ensure me that no urn has over 5 balls because this only goes up to 5. And this is going to give me the 4 for the number of urns. And for the k, I just look at the coefficient of the term with k in it. So let's maybe switch for a moment over to what we're doing here. And I could say let x equals symbols. And then I just take 1 plus x squared plus x cubed plus x to the 4th plus x to the 5th, and that to the power 4. And I write that out, and it just gives me that, but then I hit expand. Let's import it. And then expand. So now what this is telling me is these coefficients are each telling me the number of ways which I can place, well, for example, for this one, this is telling me the number of ways that I can place 7 balls in those 4 urns so that no urn has more than 5. So obviously I wouldn't want to do this by hand, but as you can see, we don't need to do this by hand. So let's alter the problem. Let's alter the problem and try something a little different. Let's say I now want, let's go back to the 12-fold way, say nothing can be empty. I know we have another restriction. It can't be too big, can't be too small, but no empty urns. Okay, so basically I have to make a choice of balls now. 1 to 5 balls in the first urn, 1 to 5 in the second, 1 to 5 in the third, and 1 to 5 in the fourth. So that's going to give me something like this for each one of these individually. And then I have 4 for my number of urns. And then I look at the k coefficient. And that's going to give me my answer. So let's try that as well. What I will do is I'll just go back to here. I'll get rid of that, and I'll toss in an expand. And boom. So now this is telling me the number of ways so that none of my urns can be empty. And notice something. This now starts off with x to the 4th, and that's because if I don't have at least 4 balls, then I'm definitely going to have some urns that are empty. And for example, the coefficient of x to the 5th here is 4 because Well, now I want to place 5. Let's go back to what we're writing. Now I want to place 5 balls in these 4 urns so that no urn is empty. Well, one urn has 2 balls and the others all have 1. So how many ways could I pick the urn that has 2 balls? Well, I have 4 choices, and that's why I had a 4 for that coefficient. Okay, but we can do even more with this. Let's say that the number of balls, this is something we can't do with inclusion-exclusion, or at least easily. We can't do easily with inclusion-exclusion. The number of balls in each urn must be odd. Okay. So still, it has to be greater than or equal to 1, no empty urns, and still, it has to be less than or equal to 5. But also, we have another condition. So, we still have our 4 urns. Each urn must have 1, 3, or 5 balls. That's very easy to do here, and this would be an extremely, well, I'd say it wouldn't be pleasant to try to do this. I mean, maybe it would. I'm sure there's a pleasant way to do it. But so what could I do here? Well, I know that each of my situations, I either have 1, 3, or 5, and that's all I needed to do. I am done. This is telling me that there's one way that we can place 4 balls into our urns with this restriction. There's no way to place 5 balls. And why is there no way to place 5 balls? Well, if I'm going to place 5 balls, then one of those urns must have an even number of balls in order to place 5, because we have 4 urns. So if I'm placing 5 balls, I'm not going to have an odd, an odd, an odd, and an odd, and then suddenly it adds up to an odd, like 5 balls. No, that can't happen. 4 odds have to add up to an even. So the problem even only makes sense if I have an even number of balls. And then just peeking back one more time, if I look over at this, for the coefficient of, say, x to the 6, well, that's the number of ways that I can place 6 balls. Well, what do I know now? Now that I know this is actually 1, 3, or 5, I'll do this. 1, 3, or 5, 1, 3, or 5. The only way that I can place 6 balls would be if I had one urn with 3 balls and 3 other urns with 1 ball. So that would mean, hey, I just picked the urn that gets 3. How many ways could I pick that? 4 ways. So you can set up all sorts of counting problems. What about urn I can hold at most I balls? So we have one urn that can hold 0 or 1. New problem. Let's start over. Urn I can only hold I balls. Okay, so urn 2 could have 0, 1, or 2. Urn 3 could have 0, 1, 2, or 3. Urn 4 could have 0, 1, 2, 3, or 4. And I want to know the number of ways that we can place K balls. Well, let's check that out. We could sort of do this quickly. Let's just, actually, we'll just write this out first. So I have 1 plus x times 1 plus x squared times 1 plus x squared plus x cubed. And then for the last one, 1 plus x squared plus x cubed plus x to the 4th. And I get that, and then I'll just expand my answer, and boom, I get my answer here. So what are these coefficients telling us? Well, they're telling us the answer to the problem. We can confirm it. As a matter of fact, we don't have a lot of time left in this video, but it's not bad to ask yourself why this 10 makes sense. Well, 4, 3, 2, 1. The 10 does make sense, and this is why we can't get more than 10. So right off, that's a good sign that I entered this into the computer correctly right there. So this is some examples of using generating functions to solve problems of balls and urns with strict constraints.